Okay, I'm just going to do a video here to show how quickly a dichroic halogen downlight heats up. This is a standard 35 watt Philips dichroic as you'd buy from Bunnings or anywhere else, and with it turned off it's sitting there at 18 degrees centigrade. The red dot you can see is the focal point of the contactless thermometer, so I'll just switch this on and we'll watch how quickly it heats up. Temperature is jumping around a bit because I'm trying to look at my phone while I hold it and the red dot at the same time, so I'm waving a little bit. So well past 90 degrees now. Now the electrical cabling in your ceiling is only rated for a maximum of 90 degrees if it's newer cable. The older cable's only rated to 75 degrees. Beyond that temperature, the cable starts to melt, and as it continues to melt, it then starts to harden. Once it hardens, it then starts to become combustible. It will start to char and will ultimately ignite. In the event that the cable doesn't ignite, the insulation will basically become ash and fall away, leaving the active copper cable exposed, where it can come into contact with metal components in your ceiling or the metal surround on the light fitting itself. That in itself could start a fire or make parts of your house live. So as you can see, we are well beyond 100 degrees centigrade now, and she's still continuing to climb. There we go, over 120. Just moving it around to show even at the outer edges of the glass, we're still up around 90 degrees centigrade. That heat will simply soak into the metal fitting of the light that sits in your plasterboard. And as you probably know, your plasterboard is simply some gyprock sandwiched between two sheets of paper. Paper exposed to that heat for an extended period of time, or the timber battens in your ceiling exposed to that temperature for an extended period of time, will ultimately start to combust. Here we go, we're up over 133 degrees now. Just trying to find that spot again for you. The red dot is focused right on where the cables come out of the back of the little ceramic clip that the bulb clips into. So these cables are being exposed directly to this heat. 130, 142. You can smell the plastic now of the light wiring. Somewhere around double of what the insulation on the cabling in your ceiling is rated for. At best, if you have the newer V90 cable, you're at more than 50% above what that cable is rated for. Now the other thing going for it here, where I've got this benched, is it's currently about 15 degrees in my shed, and this light is in open air. In your ceiling cavity it's a lot warmer. There's potentially insulation in contact with it. There's potentially shrouds installed around the light that are supposed to stop the insulation from coming into contact from the light so it doesn't catch fire, or doesn't set the insulation on fire, is the idea of the shrouds. Problem with the shrouds is that they just hold the hot air in. I'll just quickly show you one of these shrouds. That's it. It's an aluminium cup that sits over the back of the light. Well, there's also plastic ones as well. In one of the photos that I've got, you can see the burn marks on a plastic insulating shroud. Let's go back to where this is at now. We're up at 152 and climbing. This after 15 minutes of operation. So even at the outer edges we're at over 100 degrees now. More than 163. Just spent a minute trying to find a better angle to hold the thermometer at to get a more accurate temperature reading. We're finding we're up around 200 degrees now. There you go. Oh, had 202 there. Just see if I can find that spot again for you. We're at about 25 minutes of operation now in full open air. Oh, 211, 212.